Yes, please. A very good morning to all of you. Hello, Internet. This is Arun over here, and today we'll discuss about a very important cryptographic concept of key exchanging, which is known as Diffie Hellman key exchange. A very beautiful concept. I'll try to explain you this very simply in terms of an example. First of all, I'll just try to give you a simple analogy. So I am Arun and there is my girlfriend Sonia. So I have to send message to Sonia. Okay. Now inside security, I have always told you in my previous lectures also there are three important aspects of security. The first one is confidentiality, the second one is integrity, and the third one is authentication. This comes for an acronym like CIA: confidentiality, integrity, and authenticity. In terms of sending my message to my girlfriend, I'll try to explain you. So I am Arun and I am sending a message to my girlfriend Sonia, that is I love. Okay. In terms of confidentiality means that if I am sending this message to my girlfriend via a public network, this message should not be readable or this message should not be visible to all those who are present in the public network. For example, Sonia's father is present in the public network. So if I am sending I love you message, this message should not be visible in a readable format to Sonia's father. That is called as confidentiality. That is, the message which I am sending should be confident. The second thing is that it should have integrity. Integrity in terms means if I have sent a message I love you and Sonia's father is in between a public network and Sonia's father catches the message and reads the message and changes that message from I love you to I hate you. So as soon as and sends it to Sonia. What Sonia will think that Arun has sent her the message I hate him. So integrity, that is the message contents should not be changed, and for that we use hashing. Two most important hashing algorithms are MD5 and SHA, and inside MD5 or hashing also we use something which is called as salted hash. Okay, so I explained you what is confidentiality, I also explained you what is integrity. Now in terms of authentication, authentication means that if I am sending a message to my girlfriend, it should be made sure that Arun is only the person who is sending the message and there is not any other fake person with the name of Arun. So authentication or authenticity of the sender should also be maintained. In the same way, if I send a message to Sonia and Sonia's father reads that message and for my message of I love you, Sonia's father sends a message, it lost. So that creates a problem. So authenticity, that is Arun is sending the message and Sonia is also reading the message and Sonia is sending the message once again. So three important concepts of always remember of security: CIA. Diffie Hellman key exchange works on something which is called as confidentiality or encryption. That is the data which I am sending. For example, if I am sending I love you, this data should be encrypted and sent, and over there Sonia will decrypt it. Okay, so the message Arun is sending, this message should be encrypted, that is, it should be changed, it should not be readable to anyone, and even if it is readable, it should not be understandable, and it should be simple terms means Diffie-Hellman key exchange works on something which is called as encryption. Encryption is an important term of security under which it comes as confidentiality. Okay. Now, what is Diffie-Hellman key exchange? Now, key exchange also. For example, if in very simple terms, I being Arun, I have sent a very simple message love to Sonia, and also I have sent a key. Now where key comes, please try to understand, a key of 1. to Sonia. So I have sent this message also to Sonia and I have sent this key also to Sonia. Sonia reads this message and this message comes to her as love and key 1. She understands that this message has been encrypted and this key 1 means that this message love LOVE, the first letter L has been forwarded. So the original message will be KOVE. I'm giving you a very simple example. Okay. Now what happens in key exchange also? For example, if Arun is sending this message, love and the key 1, okay, over the public network, and Sonia's father reads this message. So this message obviously and the key both are available now to Sonia's father. So Sonia's father can also decrypt the message. So where is the point of confidentiality? Hence, Diffie Hellman, two people came up with a very important cryptographic key exchange concept, and this is a widely used term. So I'll just try to explain you in terms of the diagram now how Diffie-Hellman works, and just try to understand the concept of Diffie-Hellman. There are two people, and this image I have taken from the Google Wikipedia. There are two people over here, Alice and Bob. This is Alice's computer, this is Bob's computer. Okay, they have to exchange a key. Okay, this key should be exchanged before and then the message is sent, and then using the key it is encrypted or decrypted. Okay, so what they do is Alice and Bob, they use a common pin. That is, for example, Alice chooses a color in this box as yellow and sends the color code to Bob. So Bob also uses same color yellow. So now Alice has also same key which is public. Why? Because it is sent via a public network. So Alice has sent the color yellow to Bob. Alice's father also knows that the color is yellow. So now my public key is known to all. So that is now part of encryption. Okay. The next thing that Alice does is Alice takes a secret color over here, and in real terms she takes a secret key. Okay, the secret key. Okay, so the secret color which Alice has taken over here is red. The secret color which Bob has taken over here is aqua. Earlier Alice had chosen a color which was yellow. Alice sent the color to Bob. So Alice had yellow, Bob had yellow. Yellow, yellow, dirty fellow, both have same colors. Okay. Then a secret color chosen by Alice which is red. A secret color chosen by Bob which is aqua. This becomes the private key. The first one is the public key known to all. The second one is the private key which is known to individuals only. That is in our case Alice and Bob only. The mixture of yellow and red gives me a color which is orange, and the mixture of yellow and aqua gives Bob a color which is called as blue or sky blue. So Alice now has a color of orange, Bob has now a color of sky blue. The next step is that Alice will send the color orange to Bob, and Bob will send the color light sky blue to Alice. Okay, till here I guess it is understood. First is the common color, the second one is two secret colors known to only Alice and known to only Bob. Mixture of both the colors, here it comes orange, here it comes light blue. This then, the mixtured color produced is then sent, that becomes again the public key. It is sent to Bob and it is sent to Alice in cross directions. Okay. Now Alice has the mixtured color which Bob generated, and Bob has the mixtured color which Alice generated. What he does is the mixtured color which Bob had sent plus the secret color that Alice had originally. So it is sky blue plus red, which gives a color of brown. Over here Bob now has the color of orange, which was generated by the mixture of Alice. So orange plus aqua, which is the secret key of Bob, gives me a color of brown. So now you can see that the common secret key is brown, which now both Alice will also have and Bob will also have. So if I send a message now from Alice to Bob with a key of this common key, in my example a common key 1, Bob will easily decipher or decrypt it. Okay. Once again, common colors, that is a public key known to both. Secret key known to individuals only. A combination of that public key and secret key gives me another public key. That public key must be sent to the opposite person. After sending that public key to the opposite person, that public key plus the first secret key that I had, that combination is done and a common secret key is generated. This is an excellent method of public key cryptography, that to having symmetric keys. Okay, in terms of algorithm, now I'll try to explain this example. What Diffie Hellman says is that he says take two keys. These two keys are partial. First one was yellow color taken by Alice and sent to Bob. Over here, in terms, instead of yellow color, what Diffie Hellman is saying that take two keys P and G. P is a prime number, any prime number here. It is always advisable to take huge prime numbers, but for example, we are taking a small prime number. So P is a prime number 23 taken over here. G is a generator which should be a primitive root of P. A primitive root of P means that, for example, primitive root, I'll say you that for example 3 is a primitive root for 7. What does it say is that if I take from 3 raised to the power 0 to 3 raised to the power 1 to 3 raised to the power 2 till 3 raised to the power 6 mod 7, I should get the numbers 1, 2, 3, 4, 5, 6. Not in an order, but in any order, but this should be my number. Okay. So I will just show you this primitive key in terms of example. So what I said is that 3 is a primitive root of 7. So what it is saying that 3 raised to the power n mod 7 should always give you a reminder of 1, 2, 3, 4, 5, 6. Okay. And where n is equal to 0, 1, 2, 3, 4, 5, 6. Very simply, I will tell you, where take n is equal to 0. One mod 7 will give me 1, 3 mod 7 will give me 3, 6 mod 7 will give me 6, 9 mod 7 will give me 2, 27 mod 7, 27 mod 26 will give me 6. Okay, so this is how it is done. So very simply terms 3 mod 7, 1 mod 7 is equal to 3 raised to the power 1 mod 7. So this becomes 3 mod 7. 3 mod 7 will give me 3. So I have 1, I have 3. 3 raised to the power 2 now. Mod 7, 3 raised to the power 6. 6 mod 7 will give me 6. 3 raised to the power 3. 9 mod 7. 9 mod 7 will give me 3. So if you just do it by a calculator, you will understand that a primitive root number means that if 3 raised to n mod 7 and n is from 0 to 6, okay, then I should get the remainders 1, 2, 3, 4, 5, 6, 7 not in the same orders. So what it is saying that P should be a prime number and G should be a generator key which should be a primitive root of this number. Always remember. So it should be a primitive root of this number. So 5 over here is a primitive root of 23. Please do the calculations. Then, so this P is equal to 23 and G is equal to 5. Alice has and Alice sends to Bob. But remember that over here between Alice's father has the same key. So Alice's father has also P is equal to 23 and G is equal to 5. Then next is to calculate a secret key. Over here A is my secret key for Alice and B is the secret key for Bob. Beautiful. Okay, so A has taken a secret key of 6, Alice has taken a secret key of 6, Bob has taken a secret key of 15 over here. Okay, next mixture. So first it is understood, secret key is understood. Now mixture of first key and my secret key. Okay, so Alice knows P is equal to 23 and G is equal to 5 and Alice has a secret key of A is equal to 6. So Alice has a secret key over here as 6. Bob has a secret key over here of 15. Next is the mixture. In the mixture, as I told you, the mixtures will be the public key. So the formula says that G, which is my generator, G raised to A, which is Alice's secret key, mod P, which is my prime number. So that becomes the public mixture of, or the public transport of Alice, which will be sent to Bob, and this will be the public transport of Bob, which will be sent to Alice. Okay, so over here if we do, we can see that G is 5. 5 raised to 6 mod 23 gives me 8. Bob chooses B is equal to 15. So 15 raised to 5 raised to 15 mod 23 is equal to 19. So Alice will send 8 to Bob. Bob will send 19 to Alice. So now Alice has a number 19. Bob has a number over here 8. The mixture has been generated and the mixture has been exchanged. Okay, then the number which is received, the mixture number which is received by the opposite counterpart, that plus my secret key which I have. So Bob had generated 19 and Bob sent that 19 to Alice. Alice had generated 8, Alice sent that 8 to Bob. So now Alice will take the mixture of which Bob had sent, that is 19 mod or 19 raised to its secret key. The secret key which only Alice knows, not even Bob knows. Over here the secret key of Bob only Bob knows, even Alice does not know. So there is no chance of father knowing anything. So Alice computes 19 raised to 6, which is the secret key of Alice, mod 23, this is 2, this becomes my common secret key. Bob also computes 8 raised to 15, mod 23, this also becomes 2. Always remember that the common key or the secret or the common key which is generated always should be less than this P, the prime number that is generated. So in any case you can understand that the 2 is the secret key share which both have. Okay, so Alice also has 2 as a secret key, Bob also has 2 as a secret key. If Alice sends a message love with a key is equal to 2, that message will be received by Bob and Bob will decipher or decrypt the message according to the key. So this is Diffie Hellman key exchange for you. Now the known keys by the father only, try to understand over here. First, yellow color is known by the father. Okay, then the public key, that is orange, which is sent by Alice, and light blue, which is sent by Bob. That is known. So yellow is known, orange is known, and light blue is known by the father or any person Eve, which is sitting in between. So in any case, the secret key is not known to the in between person over here. Okay, so this is Diffie Hellman key exchange for you. Very simple. The algorithm says that takes two keys public key. Okay, the criteria is that the prime p should be prime number and g should be a primitive root. I have explained what is the primitive root of that. So g should be a primitive root of p. Okay, then a secret key should be taken by the person Alice, and the secret key should be taken by Bob. Alice's secret key is known only to Alice. Bob's secret key is only known to Bob. The earlier public key plus this private key, a mixture is done and another key is generated. Okay, that key is sent to Bob. In same way, Bob also sends that key to Alice. Then that is again now added with the secret key which Alice had. So this is a very simple Diffie-Hellman key exchange process which is used for encryption, which comes under the part of confidentiality. It is very easy and very simple algorithm. Try to solve as many problems of this and you will easily understand this. Very simple. Thank you. Have a good day. The aim of my video series or the motto of my life always has been that spreading knowledge is equivalent to spreading happiness. I hope you enjoyed this video. Very simple. Thank you. Yes, please. A very good morning to all of you. Hello internet. This is Arun over here. आज हम एक नया टॉपिक देखेंगे जिसका नाम है स्विच वर्चुअल इंटरफेस. अब स्विच वर्चुअल इंटरफेस में हम समझेंगे कि ये जो 3560 का स्विच है, यहाँ पे लिखा है मल्टी लेयर 3560 स्विच. ये स्विच का क्या काम है वो देखेंगे हम. इस टोपोलॉजी को समझेंगे हम. स्विच वर्चुअल इंटरफेस हमें कैसे मदद करता है इंटरव्यू राउटिंग के लिए, उसको समझेंगे हम और उसके कॉन्फ़िगरेशन को समझेंगे. वीडियो स्टार्ट करने से पहले ये बताना चाहूँगा कि मोटो इन माय लाइफ इज स्प्रेडिंग नॉलेज इज इक्विवेलेंट टू स्प्रेडिंग हैप्पीनेस. हम उसी मोटो को फॉलो करते हुए जिंदगी का. अब मैं आपको ये टोपोलॉजी थोड़ा अच्छे से समझाता हूँ. इस रेक्टेंगल के अंदर जो मेरा ये रेक्टेंगल जो है मेरा, वो है मेरा VLAN 100, दैट इज वर्चुअल लैन 100. ठीक है, इस वर्चुअल लैन 100 के अंदर मैंने अभी एक मशीन कनेक्ट किया हुआ है. यहाँ पे मैं 100 मशीन भी कनेक्ट कर सकता हूँ. ठीक है, इस मशीन का IP एड्रेस मैं इस मल्टी लेयर स्विच का मतलब ये होता है कि ये लेयर 3 में भी काम करता है, लेयर 2 में भी काम करता है. ठीक है, ये स्विच जैसे काम भी करता है, राउटर जैसे काम भी करता है. ठीक है, तो ये डिवाइस जो है इस मल्टी लेयर स्विच से वाया DHCP एड्रेस लेगा. ठीक है, इसको मैंने एड्रेस दिया 100.0.0.2. इसको मैंने एड्रेस दिया 200.0.0.2. अब हमने हमेशा ऐसा पढ़ा है कि अगर दो नेटवर्क, ये एक मेरा नेटवर्क है और ये एक मेरा नेटवर्क है, अगर दो नेटवर्क्स को कम्युनिकेट करना है तो मुझे बीच में एक डिवाइस चाहिए जो होता है मेरा गेटवे या जो होता है मेरा राउटर. ठीक है, अब मेरे पास राउटर तो नहीं है इस टोपोलॉजी में. इस टोपोलॉजी में मेरे पास सिर्फ है मल्टी लेयर स्विच. तो उस मल्टी लेयर स्विच को यूज करके मैं इंटर VLAN राउटिंग, दैट इज दो VLAN के बीच में कैसे कम्युनिकेट करूंगा, ये मैं आपको आज की लैब में दिखाऊंगा. ठीक है, वापस बोल रहा हूँ, ये मेरा VLAN 100 है, ये मेरा VLAN 100 है. VLAN 100 के मशीन्स को IP एड्रेस देने का काम इस राउटर का है. VLAN 200 के अंदर के मशीन्स को भी IP एड्रेस देने का काम है इस मल्टी लेयर स्विच का. ठीक है, तो इसके कॉन्फ़िगरेशन को चलते हैं हम. स्विच के अंदर जाते हैं. ये मेरा 3560 स्विच है. कॉन्फ़िग टर्मिनल के अंदर जाके पहले VLAN 100 दूंगा, नाम दूंगा, मेरा नाम है. फिर दूंगा VLAN 200, नाम दूंगा सचिन तेंदुलकर जो मेरा फेवरेट प्लेयर है क्रिकेट। ठीक है, ये होगा मेरा। अब मैं क्या करूँगा, आईपी डीएचसीपी एनेबल करूँगा। डीएचसीपी एनेबल करके पहला काम है मेरा एक्सक्लूडेड एड्रेस, दैट इज मैं कौन सा एड्रेस नहीं देना चाहता, तो मैं ये एड्रेस नहीं देना चाहता हूँ कोई भी मशीन को। ये मेरा लेयर 3 स्विच का एड्रेस है, वो हम आगे देखेंगे। ठीक है, तो पहला है आईपी डीएचसीपी एक्सक्लूडेड एड्रेस। इसके बाद मैं दूंगा आईपी डीएचसीपी पूल, मैं इसको मान दूंगा आरो। फिर मैं बोलूँगा भाई इस के अंदर कोई भी एड्रेस देते हैं। ठीक है, ये भी हो गया मेरा डिफॉल्ट राउटर, आई थिंक मेरा लेयर 3 स्विच का आईपी एड्रेस होगा ये हो गया मेरा काम। ठीक है, सेम चीज मैं VLAN 200 के लिए भी करूँगा। आईपी डीएचसीपी एक्सक्लूडेड 100 मेरे को यहाँ पे ये है। मैं तो आईपी डीएचसीपी पूरी मैं यहाँ पे क्या दूंगा, सचिन। ठीक है, फिर नेटवर्क मेरा क्या रहेगा, ये 200। डिफॉल्ट राउटर मेरा क्या रहेगा, ये तो ये होगा मेरा। अब मैं स्विच के अंदर जाऊंगा और स्विच के अंदर इस स्विच से कौन से इंटरफेस पे ये मशीन कनेक्टेड है और कौन से इंटरफेस पे ये मशीन कनेक्टेड है, इन दोनों को मैं एक्सेस मोड पे लाऊंगा। तो आप देखोगे कि यहाँ पे FA010 दैट इज फास्ट 2000/10 का इंटरफेस है VLAN 100 से कनेक्टेड, और FA020 VLAN 200 से कनेक्टेड है। इस दोनों इंटरफेसेस को मैं भी एक्सेस मोड में लाऊंगा। एक्सेस मोड में लाने का एक बात ये होता है कि मेरे जो स्विच है ना, ये मेरे को डायनेमिक डिजायरेबल या डायनेमिक ऑटो मोड में होते हैं। तो ये नहीं करने के लिए मैं इनको क्या कर रहा हूँ, इनको एक्सेस मोड में ला रहा हूँ। ठीक है, इंटरफेस VLAN switchboard mode access interface VLAN 200 switch mode access, ये भी होगा मेरा। अब मुझे करना क्या है, अब मुझे एनेबल करना है स्विच वर्चुअल इंटरफेस, क्योंकि अभी भी मेरे इस VLAN और इस VLAN के बीच में कम्युनिकेशन नहीं होगा। अगर जैसा हम देखना चाहेंगे तो मैं यहाँ जाता हूँ, डेस्कटॉप में रहता है और बोलता हूँ कि भाई डीएचसीपी से एड्रेस ले, तो डीएचसीपी से एड्रेस भी ले लेगा। नहीं ले रहा, प्रॉब्लम दे रहा। क्यों प्रॉब्लम दे रहा तुमको बताता हूँ, क्योंकि मैंने इसके ऊपर स्विच वर्चुअल इंटरफेस नहीं चलाया है। स्विच वर्चुअल इंटरफेस मतलब VLAN 100 के लिए और VLAN 200 के लिए इस स्विच के अंदर मैं एक वर्चुअल इंटरफेस बनाऊंगा। स्विच वर्चुअल इंटरफेस कैसे बनाते हैं देखो। इंटरफेस VLAN 100 IP ADDR जब मेरा मल्टीलेयर स्विच का वो आएगा, नो शट IP सेम वे इंटरफेस VLAN नो शट IP ADDR 200 2001 अब देखते हैं कि IP एड्रेस दे रहा है कि नहीं दे रहा। देखो पहले नहीं दे रहा था, अब दिया। अब क्या बता रहा है कि मेरा जो इंटरफेस VLAN 200 का IP एड्रेस है 200.0.0.1, और मैंने जब पहले DHCP एनेबल कर रहा था तभी भी मैंने ये बोला था कि 200.0.0.1 IP एड्रेस कोई भी मशीन को नहीं देगा, इसलिए उसने कौन सा IP एड्रेस दिया है 200.0.0.2। सेम अगर मैं यहाँ देखूंगा तो 100.0.0.2 DHCP से देगा। अब VLAN 100 से VLAN 200 में कम्युनिकेशन हो रहा है कि नहीं, हम पिंग पहले अपने ही VLAN में हो रहा है तो देखते हैं। नॉट एट ऑल एन इश्यू हो रहा है, नॉट एट ऑल एन इश्यू हो रहा है। आप VLAN 100 और VLAN 200 के बीच में कम्युनिकेशन हो रहा है कि नहीं देखते हैं। Doing normal केसेस में VLAN 100 और VLAN 200 के बीच में अगर तो मेरे को इंटर VLAन राउटिंग करना है तो मैं राउटर से भी कर सकता हूँ, या फिर मैं लेयर 3 स्विच से भी करता हूँ। मैंने आपको इस वीडियो में लेयर 3 स्विच से बताया है या मल्टी लेयर स्विच से बताया है। हम इसको कैसे राउटर से करते हैं उसको मैं आपको नेक्स्ट वीडियो में बताऊंगा, ठीक है। मेरे 200 वाले VLAN के मशीन या लैपटॉप से कम्युनिकेशन होगा क्या? रहेगा, ब्यूटीफुल। ये जो होता है ये हमेशा मैक लर्निंग के लिए ही जाता है, ये पैकेट फेल नहीं बोला जाता है इसको। ये रिक्वेस्ट टाइम आउट हमेशा मैक लर्निंग के केसेस में ही होता है, ठीक है। तो दोनों होगा मेरा। तो मैंने आपको इस वीडियो में बहुत सिंपल तरीके से बताया है कि दो VLAN के बीच में एक स्विच यूज करके कैसे लेयर 3 स्विच लेयर 3 स्विच यूज करके कैसे क्या हम कम्युनिकेट करेंगे, स्विच वर्चुअल इंटरफेस का क्या काम है, ठीक है। अगर आपको इस वीडियो के इस लैब टोपोलॉजी के या स्विच वर्चुअल इंटरफेस के लैब टोपोलॉजी के मेरे पर्सनल हैंड रिटन नोट्स चाहिए या लैब कॉन्फ़िगरेशन के कमांड्स चाहिए तो मुझे इस ईमेल आईडी gmail.com पे मेल कीजिए। दिस CACMANIT2015 @gmail.com। Thank you. Have a great day. Bye bye internet.